around each entity that needs to hold some meta information. Madan, are you there? Do you want to give an update on distributed primitives and stuff?
Sure. So quite a bit of work has been accomplished in this sprint as far as the distributed core is concerned. So one of the things that we introduced in this sprint is a new primitive called atomic value. Those of you who are familiar with the atomic reference construct in Java will find this familiar. So this is basically the same thing, but in a distributed context. So it works, like it is strongly consistent. It is useful for a group of actors to sort of coordinate on a single value, and it supports notifications and all that good stuff. So this is very useful if you want to build on top of it. So one thing that I want to highlight as part of this particular work is I was able to write this in half a day. And if you just take it in isolation, this is actually a pretty it's a complicated thing. But
what were you doing rest of the time? Don't answer.
Yeah. Well, trying to think what. So this sort of demonstrates the power of having the right primitives and how it enables us to quickly and efficiently build on top of it. So this is again available in master. Everyone can use it. They have a use case that for which it is suitable. Another thing which actually took almost half of the sprint is adding the log compaction support for the Raft implementation. Previously, we had a ever-growing log. So if you run the system at high enough load for a long duration, we would eventually get to a point where the log is pretty much all that is in memory. So this is very important for us to have the right kind of stability and also scale. So now what we do is we periodically checkpoint the log, write basically take a snapshot of the state machine, and then we can truncate the log at that point. So this gives us ability to operate the system in a continued manner, indefinitely. So that's the goal behind this. The last one, but not the least, I think this is it's hard to overstate the importance of this. Having consistent ordered notification support for all the primitives that we have is very important. It lets us build on top of this. So for example, previously if you want to know when something changed, you have to periodically poll the data structure. That is very inefficient, and also that doesn't scale. So what we end up doing as part of the cardinal release is have a notification mechanism, but there were drawbacks. The notifications are not guaranteed and they're not ordered. So it is up to the consumer to take care of those shortcomings. So they have to basically buffer these notifications and make sure they apply them in the right order. But now they don't have to worry about all that. So what we have is support for guaranteed and ordered notifications as a primitive itself. So for example, if we, as part of the network config subsystem that Thomas just mentioned, this will be a very important feature for us to build on top of. And this is available for anyone using consistent map and all the different consistent data structures. We enabled it in master yesterday, but it sort of uncovered a latent timing bug in a different part of the system. So this caused a regression. So we had to disable it temporarily. But once we fix that, we will move forward with this. So this is an important feature that was added as part of the sprint. So those are the main changes that were done in the core.
Great, thank you, Madan.
Yes.
When you say order, what is the scope of the order? Is it device event will come in, order link event will come in, and if device and link, then are random?
So yes, when we say order, so again, it sort of depends on the underlying state machine where we are tracking this information. For example, for any given key, if you look at updates for a given key in a map context, all those updates will be in the right order. across different keys may or may not be. They will be in right order if those keys happen to belong to the same database partition. But if they're not in the same database partition, then they're not in the right order. For some, like we have the ability for some maps to reside in a partition that spans the entire cluster. So anything in that partition, all the updates are ordered.
And can I add just really quickly, just to make sure that this is clear, these are the notifications affiliated with the consistent data structures themselves. These are not the same things as the events which are directly propagated to the applications. These are sort of the back-end events associated with the data structures and are usually entirely absorbed by the store, and the store then may emanate these as delegated, as essentially by synthesizing messages that are then delegated through the manager.
Yes.
Okay. So if there is no other questions on this, we can probably move to Northbound, and I'm going to let Brian give an update on that.
Sure. So the first item on the list was we've been revamping the resource management APIs. We had sort of a number of different subsystems for different types of resources, and Show's been driving the implementation and a lot of the API work for a new resource manager that would be more generic. So the implementation is coming along. It'll probably be finished next sprint. On the virtual network subsystem side, we've added an API and models for hosts, links, and devices. That code has been reviewed and committed, and we'll be starting on some of the basic implementation of our core virtual networking. There's been some improvements to REST APIs on the flows, intents, and host side. Ray is primarily responsible for helping with that, as well as some additional stuff for link load stats. On the packet service, we've now got the ability to cancel packets. It helps when applications go away, clean up the flows that they've deposited on the data plane by proxy. And we've also improved the applications that have used the packet service to use the canceled packets mechanism. So we have some examples of how that's done. There have been some bug fixes on the intent framework side and on the flow rule side. Some of those support the Internet 2 deployment. Some of them have just been uncovered during normal testing. And so that's pretty much it for Northbound.
Great, thank you. Mark, do you want to give an update on this? I presume it was you who put the netconf down, right?
Yeah, so for netconf, we engaged with Happiest Minds. They're in the process of submitting basically the missing parts for the Yang parser and an example use case, namely an implementation of a flow rule provider that is based on Yang ACL models. That should be done not today, but I guess early next week.
Great. And on the OVSDB side, the work that Huawei is doing in preparation for the OPNFV integration, they started to code well, first of all, we reviewed a number of interfaces and for the new subsystem, for the basically new controller subsystem for the OVSDB protocol, as well as reviewed number of the driver behaviors on the API side, and implementation started on these fronts as well. There is additional check-ins queued up according to Patrick, and so we will be expecting those in the coming days. But for the most part, we're trying to flush these things through the code review process faster. Alrighty, on the UI, Bree or Simon, do you guys want to take this?
Yeah. So we have a lot of new features this sprint on the topology view. Multiple links between devices are individually shown up to 4, and then 5 or more are a thicker line with like a label that says how many links are between the devices. So now it just doesn't look like one link is between the devices when there's actually more than that. we have a way to navigate to the device view to a selected device from the topology view. The flow port and group navigation buttons that were originally on the details panel on the device view have been moved out, and so you can actually tab between the flow port and group views without going back to the topology view or back to the device view. Our tabular views now flash the table row when the information in the row changes. So if there's a new item or the items are updated, then it'll flash yellow to show you that something has changed. We also have the beginnings of work on the overlays, like injecting an overlay onto the topology view. And then we have miscellaneous things. We updated the sample view archetype for the UI. There's tooltip on control buttons, so you can tell what each button does now when you hover over it. And we did various API documentation and bug fixing. And we'll have a demo for the features that I described at the end.
Great. Thank you very much, Bree. All right. Brian, I'm going to let you run with this one. Is that right?
That's fine. So in the miscellaneous category, towards the beginning of the sprint, we had Shin here from General Experts Group. He was here for just over a week and was able to do a lot of work on getting composition working for flow objectives. So this is finally merged. It's still, I would say, alpha quality. It's not distributed yet. There's still some testing to be done. But if you are interested in running multiple applications that would typically collide in flow space, the composition would be a good thing we can try. Our plan was to figure out some of the API issues first, and then once we get those proven out, move to distributed implementation of the store. But like I said, it's in the and you're welcome to try it out if you're interested. The second thing on the list is a DHCP server application. So this is also checked into the ONOS app samples repo. So far, we've got basic DHCP functionality. It's distributed application. We have a service interface with some CLIs. And this has primarily been work that Sam has been working on. The network configuration, which would enable you to dynamically change things like the IP address assignments, IP ranges, DHCP server, IP and MAC address, stuff like that, is almost done. So hopefully by the end of the week, we'll have all that checked in. And then for next sprint, we have a few things left over. Sam will be working on testing, and then there's a few other features improvements that she wants to work on. So, but that's also available. It's a good example of a more complex distributed application, and if you wanted to run ONOS on a small office or whatever network that requires DHCP, this would enable people to do so without requiring a standalone DHCP server. And I'll let Thomas talk about flow analyzer.
Great, thanks, Brian. So the flow analyzer application is just at this point in time, it's just a small and simple application. Its point is to take to periodically or on request scan the flow rules and look for cycles and black holes, and then report on them. And the idea is to build on this to make sure that it detects all kinds of different forwarding flow rules and is able to follow them until it can no longer follow them, either due to a cycle or due to a black hole. And the idea here would be that we would then eventually be able to do more than just to report on these, but also potentially repair these. For example, repairing a loop could be severing one of the links in the loop. And as far as for black holes, we can discuss what kind of approaches there would be for avoiding the black holes, perhaps stemming them from the very, very source. So that if the traffic goes nowhere, it doesn't even enter the network. The initial implementation, Nikhil provided that, and he's in the middle of testing this using various using Mininet and various REST APIs to create the different conditions. All right, Luca, do you want to take this one?
Yeah, sure.
Thank you.
So, deployment activities. Most of the sprint was spent on Internet 2. Basically, Internet 2 provided us a modified version of Mininet, trying to replicate the Internet 2 environment. So the activity was deploying that here, plus the flow space firewall, 3 instances of ONOS, so on and so forth, and different BGP speakers and routers, and do the tests. During the tests, we discovered different bugs on each side, and we created 3 patches with the work of John and Brian on this side, and with the work of the Internet 2 guys on the other side. We are waiting for Internet 2 that will provide us, hopefully early next week, a test suite, an official test suite, and then we will be able to deploy, hopefully. In the meantime, I'm setting up the physical lab that AM Light and FIU gave to us to test basically the same thing. So once we test the lab, we should install the same software and with other switches that AM Light is going to deploy, and we should just deploy it and make it work.
With a simple question, so
Yes.
ONOS 1. I should know this and I don't. 1.2 is
Cardinal.
same as Cardinal.
Cardinal.
So you are going from ONOS to Cardinal.
Yes. Yes.
And that will go into the real.
Yes.
Yes.
So the goal here is to have something not just working for a demo, which means for a day or two, but to have something that really works, right? Because if we want to move real traffic into that, we need to have something stable that stay there for, I don't know, at least 1 or 2 months without crashing, right? So Giant and Guard, this is funny. It won't be part of the demo at SIGCOM for a very practical and simple reason. That especially in Italy, everyone goes in holiday in August.
Seriously?
Yes,
How about you?
seriously.
So attendees from Italy to SIGCOM?
Yes, so except operations, right? There's this problem that there are no people there, right? And even if it's a production network, but anyway, it's something like research, so it's not an operation on the production network, and there are not people there supporting us. It's a shame, but I can't do anything for that. There are no people. They're really all away, almost, right? Yeah, and the few people that are there are just prioritized on other operational things.
Sorry, we can't do Drake. We're all going on
Yeah.
Look, you need to tell them that some of the newspaper and TV stations stopped working during summer.
Yeah. No, so I mean, the work will be in progress there, right? It doesn't mean that we won't continue, but after the holidays. Okay. We started more dialogue, at least a first meeting with Crionet and Kisti. We're starting to understand how to collaborate together in the deployments. And more are coming. Finally, well, I don't know if it was good to put it here, but as you know, we're spending some time also on our infrastructure, trying to keep maintaining our infrastructure, and we just substituted some important pieces in the infrastructure, so we hope this will make things better. That's it.
Okay. Thank you, Luca. Harry?
Actually, I'm going to present this.
Okay.
So
you guys keep me guessing since I don't know.
Most of the slide, but I make some modification, maybe easier to do it from here. So
okay.
This sprint, the QA team is quite a substantial team. We have about 6 or 7 people, some new interns, some more experienced interns. So we took on this task that to improve the test infrastructure. It's rather a substantial task to involve many stories and tasks. So the main focus is to make our tests consumable by the community, so that people can clone a code and run it on their environment and modify, make new test cases, and recommit it back to our repository, and then we can make it as a part of the production test. And so we also have to converge all the test into a two sets of production testbeds. So we finished a new workflow, which I want to do a demo later on. And then we refactor and migrate all the existing, the old test on cases into this new workflow and testbed. And then they on the functional test side of it, the migration of test is complete. And we are actually was our first time working with the outside collaborator on the IPv6 testing. We going in this knowing that we probably won't be able to complete all the IPv6 functional tests, but we were able to finish up all the test plan with the criterion. And then the rest API testing, we didn't finish, but it's in progress. HA and CHO and performance, we completed all migrating all the existing tests onto this production testbed. On the bug point of view, this 3-week sprint, we opened up the whole team 26 new bugs, and we closed 15. And altogether, if you look at all the bugs still existing today on Jira, there are still 78 bugs. So that's the progress in QA. And I hope later on we can give a quick demo on our new Garrett or QA workflow. Any questions? I'm happy to answer.
Nope.
Okay.
All right. Thank you. Thanks, Subin. Mark, I presume you will run with this?
Yeah, it's coming.
Hey, sorry for. So a couple of activities this this sprint. One is we are engaging with many different people and companies on figuring out how we should reposition the packet optical in the metro. So that basically means understanding what a metro network looks like, what are the problems, what can we bring, right? So that is ongoing. The current line of thinking is, well, we're mostly working right now on optical bypass scenarios and see how that can bring value in the metro, but it's maybe not the time to go into detail. The second part is kind of related to that metro use case is I completed support for the Calient fiber switch. So that involves an update for Loxy. We can, do the basic things with the switch because basically they have tons of extensions to do, flow rules and flow stats and not flow rules, flow stats and port stats. And then I left the remaining tasks like monitoring and dynamic topology as a future task in that it really needs a use case to drive this kind of, extra capabilities. Then with ECI Telecom, we finalized the task list to do OTN support, OTN multiplexing, right? Not OTN switching. So starting next sprint, we can start picking off tickets.
Sorry, I didn't get the name.
ECI Telecom, it's an Israeli company.
And are they going to do this? Or
Yes, they are going to do this. Yes, yeah, they committed to that.
So you're just providing them the support that they will add.
I'm not, I call with them. I don't spend any, I don't do any technical work for them. All right. PSAP tunnel improvements. Maybe Patrick can elaborate if there's questions. I don't know exactly what happened there, but
I don't think we did too much about this PCP, the tunnel enhancement, but we are planning to contribute this PCP.
So I guess this was more an investigation task to figure out what needed to be done. There is a complete list now, a good understanding. So starting next sprint, we can.
No specific coding works in this area.
Okay. And then various bug fixes, as I guess every task, every use case, and so on. That's it.
Thank you very much, Mark.
Hold on. Thomas has a question.
So for ONS, we had this, the TL1 plugin and all of that was done.
Yeah.
Anyone planning to open source it? Are you pushing them to do that?
I'm not really pushing them. I asked them on many occasions. I always got the same answer. This is above our head, the people that I interact with. So it's on your level, Guru, that these decisions are made.
Okay, any other questions?
So they were kind of rocking around ONS. They got past all that and got moving. The ECI.
Yes. Yeah.
Good.
Yeah. I think that's it, Thomas.
Okay, great. Thank you, Mark. Okay, who is going to be running with this? Is Patrick there?
Yes, he is.
Patrick.
Great. Thank you, Patrick.
Thank you.
So this is probably the first time to present this OPNFV project. So the last time when we do the plannings, I was outside the commitment, so I missed that. So this time probably give a little bit more the background information. Then we will see the summaries. So the overall, take a look at this framework. Basically, it's try to fit in this OPNFV virtual infrastructure management architectures. So you take a look at from the left side, they have Open Daylight, Open Country. That was the two SDN controllers. Is already integrated into their infrastructures and published and released in the ONOS release. So we're targeted to the ONOS is targeted to the OPNFV release 2. So here's this one works we're planning to do. So take a look at this one. So we are going to do a plugin, ML2 plugin drivers. It's in the Neutron. It's not part of this ONOS work. So within the ONOS, we have the Neutron APIs, and underneath is the network virtualization, the service layers, and the VTN is the virtual tenant network managers. The major things, another key component is support the OBS DB. So here is the blue box, the blue block is the one we're going to implement for this for this ONOS framework project for the OPNFV. Next, please. So back to this ONOS. Here is all the components we're going to modify and add. The blue one is added. The green one is we need to modify, like the tunnel managers and the host managers, the device manager, flow managers. Each one is need to be taken care of the provider networks. So the VTN is taking care of the virtual tenant networks. So we implemented the OBS DB through this driver subsystems. The Thomas is already give the introductions in the beginning. So we basically implement the tunnel drivers and the bridge drivers over there. Here is the overall component. We're going to modify it and add it. Some code in the current in this sprint, we focus on the APIs in the tunnel drivers and the bridge drivers. All these APIs and some of the implementations and some of the modifications in, for example, in the device subsystem as device managers. Yep. Okay. Next. Here is the summaries about what we achieved, the code, and the blue ones is closed. Okay. Let's start from the left side. It's the number of the ticket we opened. Total open the closed is the blue one. It's the 7, and the reviewing is the 8. We still have the 23. So there's the 61% still open. So it's a lot of work. So on the right hand side is the thousands line of the code change for each the areas. So the merged, that means the code test of code reviews now is only the 8%, and the reviewing is, oh, I'm sorry, that is 6%. So the under reviewing is 27%. We have the 20,000 more code is ready to commit. It's the 67%. So we're planning to get this done in the next sprint. So that is a lot of work.
Will be done in next sprint?
Yeah.
But Patrick, sorry, ready to submit is if the code is ready and is ready to be submitted.
Yes. Yes. So, submitted is I think it's a kind of we already implement code around the UTs. We're ready for the code review
process
okay.
before they push to Garrett.
Yes.
And so it's going through the internal code review before.
Yes. So the coding is done, but now we're still kind of hold this one. So we'll try to split it into as small as a reasonable ticket to make the code review
right.
So let me understand it differently. So you're saying by end of next sprint, you're expecting that it will be submitted and that means it is working, tested, and ready for people to use. Is that what you mean?
Yes. This is a goal, very aggressive goal. So, can
you give me an idea how many people are working on this, for example?
Huawei teams, let me see, 1, 2, 3, 6 or 7. For these guys, as not include the testing peoples. So the testing teams work with the sweeping on the overall testing plans. So a lot of the testing works include.
And the team is in China primarily?
Yes, and also include the two folks here. It's a lot of work. I don't want to stress the push anything here, but I want to see, hey, the next spring is a very tough one for the Huawei's team and the teams who doing the code reviews and all these feedbacks. It's a lot of work.
Allocate a lot of review time on site.
Thank you. It's done.
Okay. Thank you, Patrick.
Yeah, so for code, we're mainly focused on cleaning up some of the workarounds we made for ONS and fixing some of the places where we deviate from the final architecture. Part of that was we developed a set of test scenarios using OF test that we were able to send to PMC Sierra, so we can sort of have a formal way of describing what our requirements are from the OLT and the other boxes that we're using. And so they can make sure that they conform to those requirements and do the right things. And then in our setup here, we did some testing and improvements. We changed to using in-band management for the OLT instead of the old out-of-band management connection. We moved our authentication process to happen at the OLT itself instead of happening at the fabric. So previously we were passing all the authentication packets straight through the OLT and doing everything in the fabric because we weren't able to get it working on the OLT before ONS. But now we've been able to roll back a bit and do the authentication at the OLT, which is what the architecture expects. And in the same vein, we've instead of tagging subscriber VLANs at the RG, their home residential gateway, and passing them through, we're now tagging them at the OLT, which again is what we should be doing from the architecture standpoint, so that the residential gateways have no knowledge of the VLANs that are happening in the system. They're all the same, and the actual tagging happens at the OLT. Yeah, that's about it from the code.
Great, thank you, John. Those are actually pretty nice improvements. All right, I presume Shrikant is going to drive with this?
Yes. Okay, hi everyone. I'm Shrikant Erickson. I'll give you a quick update on the new use case that we introduced in this release, that is ACORD, Analytics for Code. So the majority of this sprint we have spent in understanding a little more deeper in use case. In that regard, we had multiple discussions between ON.Lab, AT&T, and Ericsson to first come up with the goals of this use case and come up with a reference architecture. The discussions are still in progress, and we came up with the first cut of the reference architecture, which I have a slide to describe that. But in that process, we understood that this use case is better to approach this use case. We can subdivide into two tracks. One is building a basic ACORD platform or core component, and then do a proof of concept to showcase the analytics in the mobility environment. So track these as two separate projects or use cases. So the quick update on the ACORD platform part is as part of the investigations, we found some interesting overlap with the OpenStack accelerometer project with the goals that we are coming up with the ACORD. So we are exploring that accelerometer project and see how we can leverage that work in this ACORD platform. And towards the mobility environment proof of concept, we are having some discussions to how we can bring up some mobility components into the existing CORD infrastructure, and how the POC lab to be set up, and what kind of networking requirements that we need from the mobility elements. So they are all in progress. So Thomas, can you move to the next slide?
Yes.
So as part of our discussions, these are the high-level goals that we came up for the ACORD platform. So as I was saying that the platform, we were trying to build a generic capabilities to enable analytics in the CORD environment such that any vendor-specific analytics solution can leverage those capabilities. So that is the primary goal of the ACORD platform. In that regard, the must-have in this platform, or the platform should allow the applications to adjust the level of probing in the underlying infrastructure devices. It should allow the applications to instrument the various services in the CORD, and it should allow the infrastructure should aggregate various probes coming from different components in the CORD, and that the last one is it should also allow some dynamic probing in the infrastructure that cannot be possible on the underlying devices. So these are the high-level goals that we came up, and keeping this in mind, we came up with a reference architecture. Thomas, can you move to the next slide? So this is what, again, this is still in work in progress, and this is the first cut architecture. As you are familiar with the CORD infrastructure, this is more or less the same, and as you see in the bottom, we have the various compute and network resources, and then we have a layer of operating systems like OpenStack and ONOS that control these resources. Then we have the CORD service controller layer. Currently, we have residential service or CDN as a service. In this layer, as part of the ACORD, we wanted to bring a instrumentation as a service. I mean, for lack of any better name, we are giving this as instrumentation as a service. But as I was describing in the previous slide, this is the platform that we wanted to provide in this use case, so that it can be leveraged by the application sitting on top of the exhaust analytic applications that can extract the various information from the underlying devices through this platform and run their analytics and take some decisions and feed back that into the network to take any mitigation actions, so that thereby you can achieve this closed loop. So this is a high level view of the reference architecture.
Shrikant, if I may ask a question. So, okay.
Thomas,
Do you want me to read?
question? Can you move back? Yeah.
No, go ahead. You have one more slide, right?
Oh, I have a few more slides.
Okay, I'll wait. Sorry.
Okay. Okay, then move on, Thomas. So as I was illustrating earlier, that we found some interesting overlap with the OpenStack accelerometer, and we are exploring if we can, if this meets all of our requirements. So that explorations are in progress. But if at all, if it is meeting our requirements, then we wanted to leverage that infrastructure to build this instrumentation as a service. So as shown in this picture, the focus for the Drake mainly around this one. So bring the OpenStack accelerometer as a first-class service into the XOS infrastructure. And today the accelerometer is integrated with the OpenStack measurements and ODL and OpenCounterrail plugins. So as part of this use case, integrate with the ONOS to get the various meterings that are available in the fabric and in the network devices. And also add a framework to dynamically insert in the runtime probe VNFs. So not all probing can be done on the fabric devices or the underlying devices. So this is the frame. This is monitoring probes that can be dynamically instantiated so that the traffic can be punted to the VNFs, which will do the deep probing. So we wanted to provide a framework to instantiate such kind of VNFs, and then extend this framework to add meters and plugins so that other CORD services like residential service or future mobility services can be monitored, and build some enriched XOS APIs surrounding so that it can bring the access control or various fancy APIs towards the applications. So this is towards the platform piece of the ACORD. Thomas, can you move to the next slide?
Sorry, just one quick question. The residential service controller, is that something that where is it from? So
That is already existing in our today's CORD demo. The VCPs, the OLT and CPE and the BNG controllers that are running in the XOS. That is what I'm referring as residential service controller.
that's as part of the ONOS.
That is part of the XOS framework. Yeah. Okay, just for a quick illustration, we brought up a OpenStack cluster in the Cloud Lab to find out what kind of metering support that is there in the accelerometer. So these are the various compute and network related meters that are available in the accelerometer. So this is just an illustration. So you can see the CPU level, disk level, image level, network level, memory. So different meters that are, and we have to, as part of this use case, we wanted to extend this metering for our service level, for residential service or a mobility service, so that applications, analytic applications can get the samples of those meters. Yeah. This is not focused or targeted for the Drake, just is a high-level blueprint on how we wanted to showcase this platform capabilities and demonstrate the analytics in the mobility environment. So the orange color pieces are the mobility-related elements that we need to bring into the card so that we can merge our card platform and this mobility network components to demonstrate this analytics. So as you see here, the mobility service controller that can get the various measurements from various mobility network elements like evolved packet gateways or mobility MMEs, and provide those analytics towards the applications, either analytics applications or policy applications that consumes these measurements and run the analytics and feed back their decision to this mobility service controller to take any mitigation action. It's still in work in progress, and again, there are a lot of discussions happening, and the things might change in moving fast, but it's high-level blueprint.
This is again that is the service controller, the mobility service controller.
Yes.
That a software module that actually it's outside of ONOS and it's also outside of XOS. But
no, it's the part of the XOS framework. So XOS framework has a service controller layer. That service controller layer knows how to instantiate the service or how to scale the service independently. So we will have a EPZ service controller, we will have a MME service controller that knows how to scale that service on the compute nodes using the OpenStack and ONOS.
Is this something that we need to write, or is up to the vendor to write it?
It could be a third-party vendor. He can bring their own mobility service controller, or like residential service we can develop. Just to analogy, the CDN is a service controller today we have, that is a third party. Similar to that, mobility service controller also could be a third party, where we need to develop a plug XOS that talks to these service controllers.
Okay. All right. Thank you, Shrikant. Is that all?
Yeah,
did you have stuff to add?
What I was going to ask you that in this accelerometer, did you say there are plugins for ODL and open
contract today existing?
So they exist. So there are examples. Is they open source or these are?
They are open source.
And then do they go all the way to the open for devices or only at the service? I mean, at a higher level. So
they go to the. I mean, today they are fetching the flow and port statistics from the open. Yes.
So we should be able to just kind of
integrate with our ONOS framework. Yes.
One quick question. So from the accelerometers to the ONOS, so what's the bandwidth required?
I'm sorry.
What's the bandwidth? When you are probing, right, you take the information from the network. Okay. Over here, it seems like not only the network, but also a lot of virtual functions, right? Everything. Correct. So from these architectures, you were through the ONOS to indicate to the accelerometers, right?
Correct.
So what's the bandwidth required between the accelerometer and the ONOS?
So today's accelerometer provides two kinds of fetching the information. One is element notifying the accelerometer, or accelerometer can poll the meterings from the underlying devices. If it is polling, you can control the polling interval, how frequently you want to poll. And
hey guys, can I ask that we take these questions offline? Okay. This is more of a design, future-looking thing. This sprint, this is supposed to be about here and now. And so I hate to be a evil police dog, but I think we should move these offline, these discussions. I would like to make sure we have enough time for agenda and for the demos. Is that okay?
Yep. Yeah, it's okay.
Thank you.
This sprint, I'm mainly testing the performance of SDN-IP. The environment is I set up several environments. This environment is succeed. The environment is fast, which is one BGP speed, 3 BGP actual peers without the flow synthesizer. The result is we can successfully learn the SDN-IP application can successfully learn about the 600,000 routes and install all the intent. And each switch is about 1.3 million flow entries inside. The total memory on those user is about from 6 to 7 gigabytes. So the conclusion you can say from the workflow, I split it into several pieces. So from the quagga to the ONOS compiled intent, from this segment, the speed is super fast. It's no big problem. The rest of the part in red color, I need to further look at it and to split it further and explore what happened there. But I know that area has something problem with the performance.
When you say disable the flow synchronizer, does that mean you lose reliability, the HA?
No.
Flow synchronizer is responsible for keeping the data plane flow tables in sync with the ONOS flow tables.
Yeah.
So
it fetch all the flow status. Then it put an overhead on the ONOS, and the ONOS has things going wrong. So I just disable that part.
If the devices behave properly, there's no risk. The risk is when devices drop or eject flows. Flow synchronizer will reinsert them on the device.
It's also when you lose connection to the device and more flows come into the flow store, they won't get these problems that are designated back to the device when it comes back.
So how long will it take to install this 1.3 million flows?
It need from the quagga to the ONOS in the blue line that area only maybe 10 or 20 is very fast. But if you run all the things together, it may be few minutes, like 2 or 3.
Ping, you're saying whatever part you wrote works very fast. The rest of
Your problem.
We are challenging rest of the ONOS team to get their part together, right?
I mean, I already tested some component of the ONOS is also very fast. I just don't have enough time to split it into to look at each step. I mean, for the red part here, I still need some time to look at it. And I also don't know whether it's because of OVS switch or because the ONOS side. When I start 1.8 milli, then things are not good. The 1.3 is okay for the OVS switch. Thomas, can you go to next page?
Yes.
Here, just I copy some screen that in the right there is from the program. You can see the number. I inserted this number of the roots. The left side is the roots learned by the ONOS and the intents it generated and insert. And the right down here is you can see the 1.3 million in the switch. Thomas,
Great.
can you I found a lot of problems so far, like the flow scanner right now is a bottleneck, and when ONOS running for some time, then it may lost some links. Then when it generates the new internet, it can't find the path. And when it runs sometime, maybe the memory is used up by ONOS. And also run sometimes the number of the roots and the intents are not same. Also, when ONOS is busy, the proxy app can't work properly. Then the BGP connection broken and the root flapping starts. Then the first page it succeeds if I enlarge the topology and enlarge the peer of the BGP peers. Then the environment will not work. So only work for that small environment. Then I found maybe two suggestions. One is I found in the flow entry we match I found we match the import and the output. If we match the import, if there are 20 paths to go through one switch, there will be a huge number of flow entries. So I think maybe we can. How about don't match the import, or we match the MAC? If we match the MAC, then ONOS don't need to handle so many traffic between the switch and ONOS. There may be a suggestion here. And also, I hope ONOS will not die. Even it can handle everything very slowly, it does not die there. This is the two suggestions. Next step planning is this sprint I manually test it, and for next sprint I will automate it and put it on the Jenkins. I also hope the testing team to take care of some, because I know you already write some functions, you already test it. Just didn't test the 600 uses number. I know you tested the flows and rerouting a lot of functions. Just put a little function to achieve this number. And I will solve the problems one by one. And I don't. The last one is for the performance. I don't know whether we should set a milestone to all people together to achieve this number, because there are a lot of pieces. I think maybe we can carry out in this way. If I will continue to split it, test it. If some component is not correct, maybe who write this model, maybe he can look at it and take care of this piece has problem. That may be much faster than myself to handle it. Okay.
Yeah, well, I think this underscores the fact that, so far we've been focused on scale out and on performance, but I don't think we've really conducted sufficient scalability testings, which actually take larger topologies and a large number of flows or intents and try to deal with it.
Well, we actually plan for a topology scale. Might as well just plan for a intent and flow rule scale. The only question is that this kind of thing is very dependent on the system setup, a system environment. So we have to just set a boundary saying this is the system, this is the flow rule we can handle, or intent we can handle. But that's something we can plan in the coming steps.
Yep. No, mine was just an observation. It was not at all meant as a criticism. So right now I think what what Ping is running into is the fact that we simply haven't done these large-scale tests. And it's similar to what Stephen Noble ran into when he tried to run with Ixia a large number of devices. So,
Hey,
all right.
Ping, I have a generic question, last one. Sorry, Thomas. Just
No worries.
wanted to know. Yeah. So, Ping, how did you get the 1.3 130K flows on one switch? I thought it's only 100K maximum, and otherwise OBS doesn't check the table full condition.
So how did you achieve to have
Is OBS
so many
handling more than?
flows if OBS?
Yeah, OBS, I thought there is a hard limit for 100K flows.
I also see that number online because at the very beginning I don't know which is wrong, which part is wrong. I get some number online also said 100, but when I really use it, even it's more than 100,000, it's okay.
It's okay. Okay. I thought it doesn't check the table full. You can just keep pushing, but okay, that's fine.
So how did you get 150 million flows for 600K routes?
Oh, if we have different peers, like if we only have one peer, we only install one path from here to from the egress to the egress who announce the routes. If we have two peers, we will install two paths. If a switch is on the way on both of the paths, then will be doubled the number. The flow entry on that switch will be doubled.
So there's a flow entry for every peer, every route, every switch.
If you, yeah, it depends on the peers and the, if not all the switch will have that number. Some switch maybe only have 600,000.
So basically for every route,
yes,
you're installing flows to get to that route from everywhere else in the network.
Yes.
And that's why it multiplies the number of flows.
Yes.
Which is why there should be coherent separation.
Yeah.
Suggestion
that's coming. So.
All right. Any more questions?
No, keep moving.
Okay. So in that case, I think we're ready to start with the demos. And so since we're starting with the UI, I'm gonna hand over the control to Bree or Simon.
That'd be good.
Did you give Bree the presentation rights?
Yes, I need to find first where there it is. Stop sharing. And Bree, make presenter. There you go. You're on, Bree.
Okay. So we had a number of features that we ended up putting in because of stuff that we saw at ONS and people giving demos that we thought we could add. People had talked about but not written stories about. So we wrote stories for them and added them. The first one is showing the actual number of links between each node. So this is a topology with 7 devices and then up to 7 links in between each of them. So up to 4 links in between 2 devices, it will show all 4. Anything 5 or above will show the actual number of links that there are with a little hash mark across it and its sticker. So that's that feature.
Very good.
If we added like a minor feature here, so you can get to the device view from the topology view by either clicking here on the title or on this button. And when you click on it, it'll go to the device view with the device that you had selected open already. So that's just a nice little navigation thing, and it works the same as it did before. Another nice navigation thing that we added was before we had the flows, ports, and groups buttons on this panel, but now they're here at the top. So when you have something, when it's deselected, you can't like navigate to these. But when you have a device open, you can go to the flows, ports, or groups for that device. So there's the flows for this device, and you can tab through those 3 here. So that's just easier instead of having to go back to the topology view like other people were doing for their presentations. And we also have tooltips on them so you can see which one is which. And then the last feature that I added was on all tabular views, but just demonstrating on the links view is rows flashing when information changes. So right now it's static because there's no information being changed, but I'm gonna run mutation rate so that you can see the links starting to change. So now the rows flash for a second and a half when the information changes. And it's any information in the table. It checks all of the things. So yeah, those are the features.
Nice. It's very, very cool. Nice job, Bree.
Yeah. On the device view, earlier we used to have some tabs for flows, ports, and groups, right?
Yeah, they've been moved. Let me turn this off. Yeah, so before the buttons, these ones up here.
Oh, not here. Once you go
Used to be
into
down
the
here.
port view or something,
Oh,
there we used to have, yeah, here, okay, that's it.
yeah. So these buttons are all still there. So now you can actually use. There weren't buttons up there before to like tab through the those 3 different views, but these are all. This is the flows view for
For the device.
null 3, and then the ports view for null 3, and the groups view for null 3. So yeah.
Very cool. Simon, you're gonna give presentation of the overlay?
Yeah, if you can pass me the controller.
See if I can. I might be able to do that.
I just.
Or can you do that?
Okay. Oh, I have to download a little thing here. Okay, so I'm going to share my screen here. Hopefully you can see it. I'm not getting any feedback that you can see it.
Right now it just turned black. I just see. I don't see anything right.
What am I doing here?
Oh, there. Now I see it.
Okay, so you can see my ONOS control window here.
Yeah.
Yes.
Yeah, you see your terminals. We see terminals. Yep.
Yeah. Okay. So these are just the applications that are in. So the first thing that I wanted to demonstrate was we now have a GUI archetype that we've updated recently. So in this directory here, I have nothing. And what I'm going to do is use the handy function script create app. And we're basically putting down the base application. I'm going to put in a group ID. So, for example, let's see, I got to say org.simon.app. And then we're going to give it the artifacts ID, simon-app. And then there's a couple more features, but we're going to use the defaults. The first one is the version, which we're going to keep as 1.0 snapshot, and then the package is also given. So what that's done is it's laid down basically your source directory structure for your base application. Now we're going to do the same thing, but we're going to lay on top of that the UI resources. Second or two. And what we now have is a directory structure with the code for both the application and the UI. There's just a minor little change we need to make to the pom.xml, and that is change the description
So just like that. And then we also need to change the application name. And I'm going to change the origin. So with those changes, we can now build the project. And as you'll see, so this is completely standalone development here, as me as a third party, if you like. And what I'd like to point out is the OR file is installed into my M2 repository. Okay, so back in ONOS land here, we've got these applications running, and we can connect the UI and see we have the navigation items. So now, if I were to do ONOS app, I'm going to send it to localhost, which is where Graph is running. We're going to install the application, and we're going to activate it at the same time. That's what the extra bang is. And then we're going to say where the OR file is. So what you see here is we get some JSON back telling us that it was installed. And over on Graph, you can see that we've got org Simon app has been installed. And if I go back to the UI and refresh it, we now have a new view that has been installed under Other. And this sample view is actually a pattern for generating tabular views. And this includes the mechanism for selection and requesting details and getting details. So that's the archetype. As you saw, right? Within 5 minutes, I've got a new view running for my application.
Very nice.
So that was that one. Actually, very quickly, in here, this is roughly the code that you get for your application, including the message handler, which gives you a pattern for populating the table using a very simple modeling. You can include your own custom formatters and comparators for the data. And then on the client side, there's a very little piece of code which you need to lay out the table in the appropriate order and so on. So that's the archetype. What I'm going to do is restart Graph here. So what I want to show you now is just some of the preparatory work that we've been doing on the topology overlays. So first of all, let's see, restart Graph. While that's restarting, I've basically created a standalone application which used the archetype as a starting point, but I've now created some code here. There's two pieces to it. One is the client side, which is a little bit of JavaScript that allows us to define an overlay by giving it an identifier. We can define our own glyph and tooltip, and we also have activate and deactivate callbacks, so that our code knows when our overlay has been activated. Similarly, on the server side, there's a class that represents a topology overlay. We're extending the base class, and we can override methods that we care about. In this particular example, we've got a modify summary method where we're passed a property panel little model object, and what we're doing is we're setting its title here. So what this all means basically is that, okay, we've got Graph running. We're going to refresh the page here. Down on the toolbar, we've rearranged things just slightly. We now have two two buttons here in a radio button set. There's one with no overlay, and then there's one that will be the traffic overlay. These will come out of the box, and this third row is where the traffic overlay will install its buttons. But as an application developer, I can create my own overlay. And so by installing this pre-built demonstration application, just like we saw before, we've now got that installed. We're going to refresh the UI so it picks up the new code. And if we look down here, now you can see that we have 3 overlay buttons. So there's no overlay, traffic overlay, and now the sample overlay. And notice also that the glyph here was something that we injected into the system. So if you remember, the overlay code on the server changes the title of the summary box. If you watch up here as I activate this overlay, you'll see now our overlay is injecting content into the topology view. So we've basically put together enough of the framework to start developing the APIs that we need to be able to do things like modifying the data that's displayed when devices are selected, being able to tell the topology view to highlight links and devices, etc., under certain circumstances. Okay, I've done enough talking, I think.
Oh, that's very cool.
Okay. Do I need to pass the baton to someone?
So you
Yeah.
Thanks, Simon.
Okay.
Thank you, Simon. So are we?
Sahil has a.
I think that. Okay, yeah, that's right. Yeah, right. So Neil, Sahil, we. One second. I think you should be able to do that by making him a presenter. I don't see Sahil. I don't see him on. Sahil, you may need to. Maybe what we need to do is change the order. You may need to sign into the meeting in order to be able to use your laptop. So you may need to.
HTML5 user viewer. You're a user? Yeah.
I do.
Yep.
Make that one the presenter.
So.
Okay, you should be.
Okay. Okay. So Thomas.
Well, hold on a second.
Yep.
Hold on a second. So who do I make? Oh, there it is. Who do I make presenter?
It's already
done. We got it.
Okay. You must have revoked my privileges because I had a still pending prompt. Okay. But I only see a corner of a screen, so something's messed up.
Is that thing always going to say?
Press the orange button on the top.
What do you want me to do?
Can you collapse the go to meetings thing?
On the right.
On the right.
I mean,
Oh, this
it's not
that,
really
yes.
Sorry.
Okay.
I got it.
So basically, with the reactive forwarding application, when we install flow rules, they stay installed as packets are getting sent. So if I, from H1, ping H3, hopefully you guys can see, we can see that flows are going to H3 through this path. And but if I take a link down, so if I take the link down between S4 and S3, the flows will stay installed and we'll have a black hole. So what I've done is I've reactively pruned the flows and until we get to a switch where there is the shortest path to the destination. So we can do that again. I take the link back up and then ping H1 to H3. Flows will once again take that same path, and then if we take down that link, and then again, flows will now take this path to the destination. So, I can even take that further and take down S9 and S6. And flows will take this path to the definition. So that was the first bit. And I've also worked on the configurations for the devices. So I will take back up all these links. So right now in a JSON file, I have specified. Okay. I specified that device 9 and device 7 should not be allowed in our topology. And right now they're already been allowed. So if I send a host to the to ONOS with the JSON file, it will automatically kick off those devices. And fortunately, I have not gotten to a place where we can add them back easily. So the only way right now is to just take them. And also, if I there we go. Okay. Now that the configuration is in the system, and if I try to take Mininet back up, those switches will be blocked from joining. And that's it. And we're
very cool.
in the process of extending this functionality to links and hosts as well.
Yeah. Yep. Very nice.
All right. Do I need to pass it on to Stephen?
Oh, yeah, sure. But can I have a quick question?
Yeah.
Is that what make the switch you block being seen by the GUI but not allowing to participate? Is that the plan, or is it just completely break it out?
It actually kicks the device off. It removes the device.
Right.
I think that's what your question was, right?
Well, yeah, I'm thinking if the GUI is the GUI is the admin way of looking at the network.
Oh yeah, I mean
you should be able to see the device, but mark it as being
from the
kicked
CLI,
out.
if you go on devices, those devices will not be there.
So you can write a Jira ticket for it.
Standard answer.
Standard workflow. Okay. So talk about just segue into a workflow. So lately, the last few weeks, we have a lot of interest in using a test framework to do testing, including collaborators, partners, and some individual collaborator coming from the community. So I think it's a good timing for us to basically refactor the test and the workflow so that we can make our test consumable by the community and also have their contribution to be useful in our production testing. So the new workflow look like basically starting from our wiki. So we have all the information about how to get started on the system test and how to compile a test plan. For example, Criterion started this IPv6 test plan. They added it on our wiki so we can review it, modify it to finalize the test plan. From there, we can go into a similar workflow as what we have on ONOS. And thanks to Brian's help, that's our new repository for the ONOS test will be on ONOS system test and backed by GitHub, as opposed to the previous way we used just the GitHub to do all the review and merge. Right now we have a review process and we have a verify process. Once those are done, they can be emitted into our Jenkins workflow, which will be included in the production testing. And this screen is showing us that currently 90 run of production tests, including the functional test, HA testing, and our performance testing. And we have a separate test bed that tests the control test, which has, we need a separate test bed because there's a long run testing. So the new workflow basically allows us to, anyone who want to contribute to the test, write the test, and then we have a way to review and accept the test and put in the production test. So I'm not going to bore you with all the results. I mean, you can see all the test logs and results from wiki, and the procedures in the wiki as well. Right, so for example, this is the results for 90 tests. And so that's my short demo from the test team.
Great. Thank you very much, Subin. So I think that concludes the sprint, unless somebody has any more questions or things to add. And we actually, was there a question?
Use case update this time?
Nope.
Is it because
Rusty didn't get us one?
Do we have any update in, I mean, how is that progressing, what's going on? Or
U.S. government finally approved direct-to-the merger.
Yeah, today is when it's like, yeah.
So now they're going to do it then?
Oh no, that can't be good. What merger with what?
AT&T.
Oh really?
For acquisition.
Oh, that's interesting.
SRI, there was no update from SRI of that particular thing?
Okay, that's it, right?
All right. Well, thank you very much, everybody. We actually ended on time, spot on a minute too.
Yeah, good job hitting the button.
Yeah. So we'll see everybody on Monday. I believe it's from 11 to 12:30 or 11 to 12. We have a sprint planning meeting for Drake sprint number 2. So I encourage everybody to start thinking about and prioritizing and identifying the stories that are in the backlog which you think should belong to the sprint 2. Okay, and with that, you guys have a nice weekend.
You too, Tom. Thanks.
Okay, bye-bye.